According to Ed Herring, principal investigator for the Carpe Diem Phase 2 flights, Carpe Diem stands for Carpet Determination and Entirety Measurements. When a plane flies supersonic, the booms come down and hit the ground in an area which is called the sonic boom carpet. A network of sensors will measure or seize the sonic booms and test to evaluate the newly developed system. NASA will utilize the Crystal Instruments Ground Recording System, or CIGRS. The ground recording system is a dynamic analyzer and a portable lightweight device which is designed to make accurate recordings in real time. The system consists of 150 automatically operated remote sensors, which were designed and tested for the highly anticipated test flight of the X-59. The system is designed to use communications from the aircraft to detect altitude, location, speed, and direction. The GRS and 4 measuring systems will quickly analyze this information and compute when the next sonic boom will hit. The recorders were set up to automatically turn on and off to capture the sound of the boom. The testing phase consisted of 4 flights with supersonic passes from all different directions, ensuring the capabilities of the ground testing systems. The testing consisted of 3 phases. Carpe Diem Phase 1 was more of a logistical test, setting up the sensors in a 30-mile array and getting the equipment ready for the sonic boom flyovers. Phase 2 consisted of making sure the equipment would work properly, setting wires and cables, microphones every 100 feet to over 1,600 feet, communicating the latest weather conditions to the pilots, ensuring that the booms could be produced and recorded. The X-59 is still not ready. NASA used an F-15 and an F-18 from NASA's Armstrong Flight Research Center for the Carpe Diem Phase 3 testing, which involved 20 supersonic passes with speeds ranging from Mach 1.15 to Mach 1.4 at altitudes ranging from 40,000 to 53,000 feet.
Houston departure, NASA 846 airborne.
3 of the supersonic passes consisted of an F-18 conducting a special inverted dive maneuver to simulate a quiet sonic boom, resulting in a super quiet thump when measured from ground systems. Ultimately, the goal of the X-59 Carpe Diem testing is to work out all the logistics and the hardware problems so that the testing flight is done smoothly and with no major issues. Thank you for watching, and be sure to comment, like, and subscribe, as well as check out my other videos on the development of this exciting breakthrough in aviation technology.